So my name is Sam Hin, and for my final project, I created this curriculum for project-based learning uh, for intro to computer science. So it's a project-based learning curriculum for intro to computer science. And so a little bit of background on why I'm doing this. I think it's important to know that STEM is education is really important. With to today's age, almost everything relying on technology. There's a huge demand to keep up with the technology, and since STEM is changing so quickly, there is a need for adaptation. So things that we learned in computer science class like 5 years ago may not even be applicable to today's age. And there's so much changing going on that there is a need to develop these skills to help bolster inquiry skills. So almost teaching kids how to start a project and how to research and how to ask the right questions is is a huge demand for this day and age. And this is what's going to help them be successful at the next level. So what is project-based learning? Project-based learning it's in the name itself. It's curriculum driven on projects rather than lecture and homework. So the curriculum it is student centered and student driven. So the students basically will receive some kind of project, and the project has some kind of problem statement or a client, and the client or the problem statement requires these few things, and the student must research, find the right tools, ask the right questions, and basically solve this problem or this project however they want. It's kind of nice because students can be really passionate about their project and they put a lot of effort into it, and you really see the creativity flourish within these students who do these projects. So one of the main parts about this course is it teaches students how to learn. So the students learn how to ask the right questions, how to solve the right questions. It teaches them how to plan things out, communication with other people. These are all skills that are necessary for this day and age. Like I mentioned before, with the very changing technology field. So like I said before, what my final project is a project-based learning course for Intro to Computer Science. Um, so So the course is intended for a full year or a semester. So what I created were a bunch of guides, and so the instructor would use these guides to help out the students and things like that. You can compress it down to a semester, or if your institution allows you a full year to teach computer science, you can also stretch this out to a full year too. Obviously, having a full year will make this course more effective, but it can be done in a semester. It's intended for high school students. Um, so this is kind of an interesting course because it's almost a hybrid of project-based learning and a traditional learning environment where it's lectures and problem sets. Computer science does have a very large learning curve, and what these lectures, though they aren't in a lot of detail, what they are meant to do is almost just kind of serve as that boost to help guide the students on the right path so they know what to research and know what tools they're going to need for their projects. So there are lectures, not many of them. There's, I believe, 12 total lecture guides. And these lecture guides, I'll go into detail about them shortly. There's problem sets. These are meant to be done, at home, outside the classroom, and they're supposed to kind of complement the lectures. And then we have the projects, which are the real meat of the course. And what this does is projects will. This is where they learn. So the thing about this course is the problem sets and the projects are being done at the same time. So projects and problem sets, so things they might learn from a problem set, they can apply to the project right away. Or something they learn from the project, they can apply to the problem set right away. So it's kind of a hybrid between these, and students are juggling a lot of things at once, which is what we want. We want them to learn to multitask and plan things out, and this will help further their inquiry development. So the curriculum is very basic. They're just learning how to program in Python 3, and these are the big things I want to hit within the curriculum. So data types, variables, loops, conditionals, and functions. So very basic. Not a lot of guiding right here, but all these topics right here, there's so many branches off of them, and this is what we want the students to realize, these branches off of this very basic curriculum. So the core competencies I want to go over are these. And so one of the goals of this project-based learning is we want to work on these right here, the competencies, the concrete experience of just working in groups, reflective observation, so that's gathering information and organizing and planning, things like that. Abstract conceptualization, so that's testing, constantly revising their ideas and things like that. Trying new ideas, see if they're good or not. And active experimentation, so this is like the actual implementation and making decisions. And being able to adapt. That's something that is definitely needed. So let me first go into, give you an example of one of the lectures of, the course. So this is a lecture, this is like the first lecture you give. It has an activity, which basically teaches students how does a computer work. And then what they do is they have a discussion. What this does is what we're trying to do is not only have good information in the lecture, we're trying to just kickstart these inquiry skills. So they kind of reflect on what they just did, and then what you do as the instructor is important to kind of bring it back together and show that these things, these reflections, and this experimentation that we're doing in the lecture, it comes back and it's all related to computer science. So this is this is in the document. You guys should check it out. And this is one of the lectures. So here's an example of problem sets. The problem sets are like smaller projects, much smaller, and they should be typically done within an hour or less. So some of them, they vary from researching, from creating your own program and things like that. So what this problem set does is basically you're given a program, and what we want to do is we want to basically bolster some experimentation skills. So what happens when you add two integers together? What happens when you add a boolean and a string together? What happens when you add a string and an integer together? So this is just getting the students to experiment with the code, trying to break things and seeing what they can accomplish with this. So this is one of the problem sets. Like I said before, problem sets are meant to be small, done in concurrently with the projects. So what the ideas they get from props that they can apply right to the projects. And then the last thing I want to show is an example of a project. And so here's an example of a project where the students have to create a learning activity. So what I want them to do is create a learning activity to help a student learn a foreign language. And so that's the problem statement. And whatever they want to create, they can create. So they'll have to research what is an effective way to learn a new language, and how can they create something to help another student learn the foreign language. They also, in this project, they have both the project statement and a client. So I want them to find a client, which would be a teacher of a foreign language, and that will help consult them along the way. So so they have a huge chain of communication that they have to follow, and following requirements and things like that. So this is an example of a project. As you can see, it's very open-ended, and there is some kind of plan that I put out there for the students to follow, and it's a project cycle. And so let's go back to that example, processing the problem statements. So creating a game to learn a language. They have to research what tools are they going to use, what are they going to do, what's the best way to learn a language, things like that. Planning is very important. They have to basically create a task list, something that what we did in this class, creating a task list. It's important to really emphasize meticulous planning, because that's going to make a project run much better. Then there's implementation, actually creating it, and there's testing, feedback, reflection, revise. And 4, 5, 6, 7 is just an unending cycle, or not an unending cycle, it's a cycle. These things those steps are going to be repeated multiple times until the client is satisfied, until the project is completed, because it's important to test. It's very hard to just create something and it's perfect on its first try. That's not true, and so it's important for the students to learn about that. And then after the project is completed, it's important that you have the students present the project and almost try to sell the project to you. Those are the main keys. So this is an overview of my course. If you look in the video description, there'll be a link to the curriculum, the lectures, the problem sets, and then the projects, and then the syllabus too. So just check that out. You'll definitely see a lot of great things. And this project-based learning, again, is to teach the students how to learn. And it's less focused on the curriculum. The curriculum will come, but with the students learning these inquiry skills, these innovative skills, they can be more creative in the workplace or at the next level even. And having these critical thinking skills is just so important for this day and age. Thank you so much. Here are my references that I used to complete this, and thank you so much.